Hello, boys and girls, and those who aren't. Have you ever wondered why a lighter object accelerates faster than a heavier one?
Like the difference between a car rolling down a hill and a ball rolling down a hill?
Well, that's because of Newton's second law.
You mean the guy with the apple? He has laws?
Yeah, he does. And he isn't just the guy with the apple. He's actually a genius who invented most of what we know about calculus and physics.
Actually?
Yes, he had 3 laws: inertia, acceleration, and as well as action and reaction.
But what does that have to do with my balls and cars?
It deals with more than you could imagine. But before we jump ahead of our lesson, let's first talk about the second law of motion, or the law of acceleration and net force.
Newton's second law states that the acceleration of an object depends on its mass and applied net force.
But miss, what's a net force?
Great question, Xiyena. Well, the net force is the sum of all forces applied on an object. So here you would have a ball, and say a force of 5 newtons is applied to the right, and then another 10 newtons is applied to the left. So the total would be 5 newtons to the left.
That makes sense, but how do you find the net force?
Another great question. So you can find the net force by multiplying the mass of the object and its acceleration using the equation F equals ma.
That makes sense, but what does that have to do with the difference between a ball rolling down a hill and a car rolling down a hill?
Well, now let's look at an example problem. Let's say you have a car with a mass of 1,200 kilograms and a boulder with a mass of 500 kilograms, both rolling down a hill with a net force of 25 newtons. Which one would have a higher acceleration? So now let's start off writing what we know. So we know that the car weighs 1,200 kilograms and the boulder weighs 500 kilograms, and that they both have a net force of 25 newtons. So now we would plug in what we know to our equation. But first, we have to separate A in order to find acceleration. So you would divide mass by both sides to cancel it out, and you'll get acceleration is equal to net force divided by mass.
Oh, I see. Now can I try?
Great job, Xiyena. You applied the equation perfectly. But don't forget to write down your units. So it would be meters per second squared, and then newtons for the net force. Don't forget, kids, it's very important to apply the units or else you'll be docked off points. Now, this relates to your balls and cars because we see that an object with more mass has a smaller acceleration, while an object with less mass has a higher acceleration.
Okay, but what would the difference be if they had the same mass but different net forces?
Great question, then, as expected from you. So this time we'll be looking at the same boulder at 500 kilograms, but in 2 different situations, with an applied net force of 30 and one of 60 newtons. So now let's put it into the equation we had before, where A equals F over m. When we solve the problem, we see that the boulder with a greater applied net force has a higher acceleration, and the one with a lower applied net force has a smaller acceleration.
What? So now can we test this out in real life?
Yes, as a matter of fact, we can. I have an example set up for us in the next room. Okay, students, so this is our little lab, and we will be using this car with an applied net force of 15 newtons to see the difference between the mass and how fast it will take to get here to this end line with a stopwatch. Now we test it with its regular mass. Now I'm adding more mass, so let's try it again. Okay, now students, with our example problem and lab we just did and the notes I went over, we now know what Newton's second law is about. More mass equals less acceleration, less mass equals more acceleration. Action.
physics is cool. Now we'll see you in the next lesson where we go over something else.